jumping to topic, let's see few quotes which I saw last week. And if you're attending this webinar first time, so we'll do this in every webinar. So few quotes which I have seen, which I liked in last few days. So you can see here. So generally, what you see is like people who are successful are smiling, socializing, playing sports, attending schools, right? But we don't see is like what are the efforts they are doing. So they have like lots of joint pain, headaches, vomiting, but in spite of all these problems they keep on going. That's why they are successful. But we only see their smiling, playing sports and public speaking, but we don't see their anxiety, financial worries. So we should keep on growing and keep on giving our all efforts to whatever we are doing. And this is a time management. So we should also see what kind of things are urgent to us and which kind of things are not urgent to us, because everybody has 24 hours, but some people are more efficient and some people are less efficient. Efficiency is the game, right? Even the CEO of Google has only 24 hours, but he has more efficient than us because he divides his time into urgent and non-urgent, and he give all the focus only or to urgent tasks, not on the trivial or not important tasks, right? And this is one other quote which I have seen last week. So people are not afraid to start their dreams. They are just embarrassed to be seen starting small. So when I started these webinars, YouTube videos, I do not know anything about how these things like email marketing, videos, making videos, video editing, etc. work. But I learned and started small, and many people told me that there are many trainings available, videos available, who will watch yours. But I want to tell you, I got immense love and support, and my channel is growing continuously. It is growing slowly, but it is growing continuously. So never be embarrassed to be seen starting small. Just start whatever your passion, whatever you are liking, just small. Just start small. There is no worry. Someday it may be grow bigger, right? And this also I like. A gem can't be polished without friction, not a man perfected without trial. So keep on trying. So you will be perfected one. And this is what I made this. So after reading few books, so you do not get what you desire. You only get what you deserve. And desire becomes deservingness only through these 5 points: CDSIE: consistent, directed, self-motivated, and the intelligent effort. So you don't have a choice. Can't skip any of the 5 if you want to become successful in your life. So you should be consistent, directed, self-motivated, intelligent, and you should give lots of efforts. And never lose your childlike curiosity. Be a lifelong learner by reading books, taking online courses, learning from mentors, experience new things, because the highest ROI comes from investing in yourself, right? So because like I always spend at least like I have kept some budget of my earnings. Like I will spend 5%, 10% every month to learn new things, to do new courses, right? So you can also invest something in your new courses, whatever you're liking, be it Python, AWS, whatever, right? So please invest something in your courses, right? Because those who keep learning will keep rising in life. Always remember, my friends, those who keep learning will keep rising in life, right? So I think enough of motivation, and let's jump to the topic. And before jumping to topic, I want to say one thing: your involvement in the class is critical for you to benefit most from this webinar. I request you, if it is not absolute necessity, then please close your Outlook, social media, Facebook, WhatsApp, etc. if possible, because it's a proven fact that there is no such thing in the world called multitasking. Even a genius can't do 2 tasks at the same time. So it's my kind appeal to everybody: please close all kind of social media or any kind of distraction, right? So are you with me? So if you are with me, can you please write yes in the chat box, and then we can begin. So these are just the list of abbreviations. So when I share this PDF with you, so you can have look on these things. And these are the 3GPP protocols which I used for making this PPT, and I've used various other books and various other YouTube videos also to make this video. Okay, so the first topic is the wireless world. So to set up the stage, let's talk about RAN first. Okay, so radio access network. So these are the commonly known cell sites. Okay, so these are the strategically placed to provide wireless coverage to user within a specific geographical area. Okay, So you can see it all around you, okay? And you can see it everywhere. Actually, the placement of radio access network or RAN components such as cell sites is crucial to ensure that users have reliable access to the network service. So when you are planning the deployment of a radio access network, network operators consider various factors such as population density, or they will see the topography, or they will see the building density or traffic patterns, right, within the coverage area. Ultimately, they are looking for the highest ROI, right? So by analyzing these factors, network operators can determine the optimal location and the configuration of RAN to ensure maximum coverage and the capacity. Okay, so thousands of radio access elements create seamless coverage and mobility. So whenever you want to go from one place from New York to California, so you should have a seamless coverage. So you will not make a drop call, right? Okay, so wireless telecom system components are composed of three main components or parts. So first of all, we have this user terminals. So these are the user equipment for 3G, 4G, 5G, and in 2G, as you know that it is also called mobile station, right? So other examples can be phone, tablets, laptops, and other mobile devices that are equipped with wireless connectivity features. So the user terminals are can be 3G, 4G, 5G, 2G, and it can be tablet, smartphone. Then the user terminals are connected to the radio access network or RAN. So the RAN is responsible for providing the wireless connectivity for mobile device. And the radio access has various parts, like it has antenna system, or it can be radio, and it can be BBU, right? So RAN consists of mainly three parts: antenna, radios, and the baseband unit. So these two are connected through an air interface. So we are using a wireless connectivity, and we are using a different set of frequencies, and we call it radio frequency. Okay. So radio access network is then connected to the core network. So the core network is responsible for managing the overall operation of the network. So these are the main components of a wireless telecom system. And you have the user terminals, you have the RAN, and you have the core net. And these are the, you can see various technologies on the evolution of mobile communication. So first of all, we have 1G. In 1G, we have AMPS, which is Advanced Mobile Phone System. Then we have TACS, which is Total Access Communication System. And then we have this NMT, Nordic Mobile Telephone. After that, we move to 2G, which is also called GSM, Global System for Mobile Communication. Then we move to 3G, which is UMTS, Universal Mobile Telecom Service. And then we move to 4G, which is LTE, long term evolution. And then we are in 5G, which is NR, new radio, and it provides diverse opportunities. It can be EMBB, it can be URLLC, it can be MTC, it can be vehicle to everything, right? V2X. So these are the main diverse opportunities offered by 5G. Also, we should know the names of various generations as well. So in 2G, we call it GERAN, GSM Edge Radio Access Network. In 3G, we call it UTRAN, UMTS Terrestrial Radio Access Network. In 4G, we call it EUTRAN, Evolved UMTS Terrestrial Radio Access Network. And in NGRAN, we call it Next Generation Radio Access Network, right? So these are the few names we should always remember. So let's move to our first topic, RAN evolution to 5G and 5G architecture. And before jumping to this topic, please let me know if you have any question. You can write in the chat box, please. So someone asks, what is topography? So topography is basically natural and artificial physical features of an area. Examples can be like land masses, oceans, lakes, rivers, mountains, volcanoes, plains, right? So these are the few examples of topography. Okay. Any other questions? Good question, guys. Okay. Thank you. So let's move to the next topic, which is RAN evolution to 5G and the 5G. So let's remind ourselves a couple of things about LTE, RAN architecture. I remember when I was teaching LTE, what we have a tower. On the top of the tower, there is an antenna, right? And then we have radio, and we also have BBU, and then we have a router, and with the help of router, then we have this core, and with the help of this backhaul, and radio is connected to antenna with the help of coax, and BBU is connected to radio with the help of fiber. And okay, so it was initial LTE days. So we have antenna, radio, and BBU, and then we have router to connect backhaul to core. We have fiber connection between BBU and radio, and coax between radio and the antenna. And we bragged all the time, no radio network controller like in 3G, and all the functions moved to the site, and everybody was happy. But then comes the LTE Advanced. In LTE Advanced, we have same thing. We have a tower. On the top of the tower, we have antenna, we have radio, we have something called CPRI connection, and then we have BBU. Then there is also CPRI, and we have fiber, and then BBU has a router, and router is connected to core, right? And again, between radio and antenna, we have coax, and this is, we know, is fiber, and this is LTE advanced. So here also we still have antennas, radios, and coax between radio and antenna. But in this case, 3GPP has decided for some sites that baseband unit at one common place, so it can coordinate with other sites, and we can pool hardware at one centralized location. And they have something called CPRI. So then router, with the help of router, backhaul is there, right? So I can have baseband unit at a site or common location where we can coordinate. And this is better than previous solution. But neither of these solutions were perfect. For example, here maximum 15 to 20 kilometer fiber is possible. For also for some sites, these scenarios may not be possible because some sites are very far and BBU may not be centralized at one location. So then I can't get coordination and pool hardware. So this solution is better than LTE, but it is not the perfect solution. But now in case of 5G, we have third scenario. So in 5G, what happened is, so in 5G, same, we have tower, we have antennas, then we have radios, then we have one thing called distributed unit, then we have one thing called centralized unit, or you can say CU, and this is connected to the core. Okay, and same between radio and antenna, we have coax. Between radio and DU, we have fiber, and here we have Ethernet, right? So what does 5G does? So in 5G, we may have better things possible. So here BBU is divided into two parts. One is distributed unit, and one it is called centralized unit. You may have heard this term DU and CU. So I have benefit of coordination of sites and the pooling of hardware, and I have an Ethernet interface between CU and DU. So here I have fiber, radio, and coax. And please do not think of active antenna at this point of time. We can discuss that later, but just consider as a simple antenna. So it makes sense to some of the functions of BBU at side, and it makes sense to have some of the BBU functions at the centralized unit. And this is how they figured it out. So baseband unit is divided into DU and CU, and there is no distance limit because this is an Ethernet cable, right? So one point to note here is that there can be one DU for a site, or there can be couple of DU, or you can say one DU for a pool of sites as well. So this can be possible. Again, let's see how RAN evolution to 5G. So again, how the RAN evolved to 5G. So here is our distributed base station, RAN access network. So this is what we were at about 15 years in early LTE days in the mid 2000. So we had something called baseband unit, or BBU, at the site, and BBU is connected to the core with the help of fiber or Ethernet backhaul. Then all those layers or all the protocols at the BBU, right? Physical layer, MAC layer, RLC, RRC, and PDCB. And this is connected to the RU with the help of fiber. But as the time progressed, we moved to CRAN, centralized RAN. Because fast forward from 2005 in time frame to say 2015, 2014, we are seeing operators doing what is called CRAN, or centralized RAN. So here we are taking that BBU, of the bottom of the tower, and you are centralizing those into a facility. This is called, also called, sometimes you may have heard the term baseband hotel. So it provides a lots of benefits in terms of cost and ability to maintain efficiency, right? Also to make sure that certain functions work well, like ICIC, carrier aggregation, all these functions, right? So CRAN can make them work more efficiently. So in CRAN, BBU hardware is located in single geography, generally in a hotel room or at a centralized location. And just for your information, the actual concepts comes during Beijing Olympics in 2001, in 2021, 2022. So we should know that if you hold BBU in cloud, it is also called Cloud RAN. This we have already discussed in our previous sessions, so you can go through those videos if you want. And ultimately, we have moved to 5G. So what is happening now? What I said earlier, we are splitting the BBU into two parts. One is DU, which is distributed unit, and one is CU, which is centralized unit. So here we are taking the higher layers and putting them into the CU, and you're taking the lower layers and putting them into the DU. And it can provide you many benefits. And some of the benefits being better performance, like you know that layers like MAC layer and RLC layers, they need feedback. You may have heard of this term called ARQ and HARQ, right? And feedback takes time, right? So if you put all these layers away from the node, then it can affect your latency. But in 5G, as we know that latency is the very important. So by reducing these things, we can reduce the latency, because some of these layers are time stringent layers. And these layers may be responsible for modulation, demodulation, coding, decoding, scrambling, descrambling, ADC, DAC, FFT, IFFT, right? So MAC layer is responsible for scheduling. And less the distance between scheduler and UE, lesser the latency. So in 5G, we have distributed architecture where BBU pool is further divided into DU and C. So mid-haul provides lots of flexibility to customers, especially in terms of latency requirement, right? So this is how our RAN evolved. So let's see how 4G to 5G network evolution. So let's see the evolution in terms of LTE nodes. So in 4G and 5G, we have various nodes. In 4G, we also call it, what do you call it? EPC, EPS, Evolved Packet System, or you can say it SAE, System Architecture Evolution, right? So we have various nodes. So first one is, you can say, is UE, right? Then we have this number 2 is EUTRA. Then we have this EUTRAN. Then we have this EPC, which is Evolved Packet Core, right? Then we have this PDN, and we have this VoLTE. This is for VoLTE call, right? This is U, and then we have this PDN, right? So this is our 4G. These are the various important nodes in case of 4G, right? So in case of 5G, it is called 5G system, right? 5GS. And here also we have UE, then we have NR interface, then we have this DU and this CU, right? So this is also called 5G RAN or NG-RAN. Then we have this number 4 is 5G core, and then we have this VONR. Like in LT, we have voltage over voice over LT. In case of VONR, we have voice over new radio, right? So we have seen some of the changes from 4G to 5G. We know that we have a new interface, the new radio interface, and we know that we will have a new 5G G node B that supports the NR air interface. All right. So in LTE, we have an evolved packet core that was based on vendor specific hardware and software. In 5G, we are going to have a virtualized core, and it is to be composed of various functions. Of course, 5G will support IMS, PSTN, public switch telephone network, and external data networks as well. So we are going to a cloud type of architecture. And also you can see here CU and the DU as well. This is very important concept which will be used for our CUPS, which is control plane and user plane separation. Okay. LTE and 5G network architecture. So here you can see 4G and 5G differences in terms of architecture. As we know that in past with LTE, you have all packet core, and the main nodes can be MME, PCRF, SGW, and the PGW. Well, in 5G, as I said, we are going to now replace these dedicated hardware solution with the virtualized software solutions. So here we show here various nodes like AMF, access and mobility function. So always focus on the word F. This is function. So whenever you see F, function word should come to your mind, and whenever function word come to your mind, software node should come to your mind, that it is a software node, right? So we have seen all the new 5G next generation core, and we have a new base station called G Node B here. So we have a all new core network that is based on network function virtualization and SDN, which is software defined network. Okay, so let's talk about little bit of 5G architecture as well. And you can see here N interface. Earlier, you will, if you remember LT, in LT we have S interface like S1 MME, S1U interface, S5 interface, right? So here we have N interface. For example, N2 is the interface for carrying the control plane between the G node B and the M and the AMF, right? You can see here AMF. AMF is access and mobility management function. The N3 interface is going to be interface you are carrying user plane. You can see here N3, which is carrying the user plane data from G node B to the UPF, right? Okay, so we have various nodes in 5G like AMF, which is access and mobility management function. Then you have SMF, which is session management function. Then you have UPF, which is user plane function. Then you have this PCF, which is policy and charging function. Then you have this UDM, which is unified data management. And then you have this AUSF, which is authentication and the server function, right? Okay, so 5G architecture details. So earlier that in 5 we have various nodes, and in 4G also we have various nodes. So all those nodes which were in 4G are required in 5G as well, only the name change. So you can see here, so in 4G we have various things like E node B, we have MME, we have SGW, we have PGW, we have HSS, we have PCRF, right? So here also we have various nodes. So here we have G node B. So earlier we call it E node B, right? So earlier we have MME. So all the functions of MME are given to these three. So MME functions are split between SMF, AMF, and AUSF. So it is equivalent to MME. We'll not go in details about these, but you should know these things. Then we have this, we have SGW and PGW. So in case of 5G, there is no SGW and PGW. It is replaced by UPF, SGW and PGW. And then we have HSS, which is home subscriber server. So here HSS is replaced by UDM, unified data management, right? So it is replaced by HS replaces. So UDM replaces HSS in case of 5G. And then we have this PCF. So PCF replaces what you call as PCR, right? So for more details about this, you can go to my previous YouTube videos. So one more thing you should remember in case of 5G is that a 5G is a SBA based architecture. SBA is service based architecture, right? So service based architecture provides a modular framework. So with SBS, common applications can be deployed using components of various sources and the suppliers. That's why 3GP defines SBA, service-based architecture. So visualize service-based architecture like this. So when you go to a big mall, right? In big mall, you enter the mall, then you go to shop, then you pay by credit card, and then you take the things out. But in case of service-based architecture, think of Amazon, right? So for Amazon, you go to just website, enter your login password, and then search for few things, and then you just come out. So you're doing all things on a website. You don't have to go to physically things, right? So this is a difference between SBA based architecture and normal architecture, which were in the LTE, 3G, or 2G, right? So this is way you can visualize what is SBA based architecture and what is a point to point or reference architecture, right? So here we have various nodes like NSSF, which is network slice selection function. Then we have this NEF. NEF is network exposure function, and then we have this NRF. We'll not go in details because that is already mentioned in the YouTube video. So you can go to NRF, which is network repository, right? So these are the few things we should remember. So next topic will be our dual connectivity, right? Okay. So let's move to dual connectivity. Okay. So let's first understand what is so-called dual connectivity. So let's take few words and let's read the definition of dual connectivity. So dual connectivity is ability and the capability to transmit, receive two streams of data packets from two radios simultaneous, right? So this is the definition of dual connectivity. So here it says very clearly ability and capability to both transmit and receive. So this is very interesting as far as telecom is concerned, right? Because transmission and reception philosophies are different, right? So we should able to transmit and receive. And here you can see two streams of data packet from two radios. One is, you can see M. So here you can also say it is MN, which is master node. And here is SN, which is secondary node. Okay, so this is where your dual connectivity comes into the picture. So now, having said that, let's understand this diagram. So there is something which called master node and there is something which is called as secondary node. So that is the nomenclature we are following in this particular session. So now we have master, we have secondary node, right? So what actually master node does and what actually secondary mode does, so and how these two are getting connected, right? So that is what is going to be very interesting thing, right? So we'll learn these things in this particular session. So prior to that, you can see here I put the color. So blue is the carrier 3 and 4, and light green is carrier 2 and carrier 1. So the moment you say two different carriers, you should able to recollect, right? So we talked a lot in LT. For example, say, oh, it is something similar to carrier aggregation. So your guess is right. The answer is yes, but that is not the end of the story, because it has many more things we are going to do here. But that we'll discuss later. But if at all you guess that way, you are right at this point of time. So having said that, so there is a master node and there is a secondary node. The moment you say the master node, why we call it master? Because master node is the one that is actually connected to the core network through the control plane as well as the user plane. So if this site is down, there will not be any call, right? Then there is no use of the secondary node, because master has the control plane, master has the signaling. So if there is no signaling between UE and the radio, then how can we talk, right? So master node is called master because it has the control plane signaling, and we are sending the data from master node, and also we are sending the data from the secondary node, right? That's why it is called secondary. That's why it is called the master node. So the master node actually controls a complete RRC path. If you have heard of what you call SRB0, SRB1, SRB2, so these are controlled by master node. That's why it's called master. And one more thing, so when to add a secondary node, when to remove a secondary node, what conditions we have to add and remove the secondary nodes, that is also controlled by a master node. That's why it's called master node. So lots of controlling information will typically go through the master node. And with that introduction, so we have understood that a particular subscriber can receive two different data streams, right? And two different data streams at the same time from two different base stations is a very interesting concept, right? New concept. So that's where our dual connectivity comes into the picture. And we'll see more details. That this is not the end of the story, and we have just started. So first important terminology we have learned is the master node and the secondary node for the dual connectivity. All right, we have two base stations that are simultaneously connected to the UE, right? So let's talk about more terms in the dual connectivity. So we have the master node, right? And we have the secondary node, as we have talked about. What about the cells that belong to those nodes? Well, all the cells that belongs to the master node, they are something called MCG, master cell group. All right, and the group of cells served by master nodes belonging to master nodes are called the MCG, right? So group of cells that belongs to master cells are called master cell group, and we are going to have primary cell in the master cell group, and we have the secondary cell, as we have discussed and as we have learned in case of carrier aggregation, right? One is primary cell and one is secondary cell, right? And we can do carrier aggregation between the primary cell and one or more secondary cells that belongs to the master node. Okay, and one big thing about P, why it is called primary, because it is the signaling anchor. As I said, it is the signaling anchor, right? And it has the RRC connection, right? So if it is down, call will be dropped. Then we have secondary node over here, and all the cells belonging to the secondary node are called secondary cell group. And we also have primary cell here and secondary cell here, but only small difference is there. The primary cell belonging to secondary cell group is called the PS cell, just to distinguish the primary cell of MCG and the primary cell of SGG. So it is called PS cell, and here it is called only P cell, right? So just introducing new terminology. All right. So for this multi-rat dual connect. So this definition we have discussed. So what is dual connectivity? What is primary cell? So primary cell operating on a primary frequency, secondary cell operating on a secondary frequency. Then we have this master cell group. Then we have this secondary cell group, and we have PS cell, right? So the SGS cell in which U is instructed to perform random access when performing the SCG change procedure, right? So these are the concepts we have just learned. Now the question comes to our mind, why we need dual connectivity? What are the various benefits of dual connectivity, right? So one of the most important reasons shifting from 4G to 5G or 6G or 7G is the capacity, right? So nowadays many people are watching YouTube, Netflix, high definition TV, and all these things required capacity: video calling, AI, ML, virtual reality, augmented reality. All these things required lots of capacity. So the question is that, can I increase capacity with the help of dual connectivity? So capacity is very interesting word, right? Capacity could be user capacity. Capacity can be throughput capacity. So can I give more and more throughput to user? The answer is yes, right? Because I can push more and more data. Also, can you support more subscribers? Answer is yes, right? So in both ways, I can use the user capacity and the throughput capacity, right? With the help of dual connectivity, we can increase both. Other interesting thing, as far as mobile network is concerned, how can I minimize our handover failure rate? Or you can say the mobility control. So that's where your mobility comes into picture, right? So here you should articulate one interesting point. So there is something just single connectivity versus dual connectivity. So what do you mean by that? So initially in single connectivity, I have only one base station at a given point of time, and I am providing the service, right? So here we have only in single connectivity, we have only one base station A, then we have base station B. So when the U is moving from one place to other, he has to do the handover, right, from A to B. But in dual connectivity, two base stations are going to provide the connectivity, right? So at one moment, there can be possibility that user is connected to these, right? This belongs to maybe LTE, and this may be A1, this may be A2, it may be G node B, right? And at this moment, U may be connected to both, right? So in this case, what happens is handover success rate will increase. Our handover failure rate will typically come down, because it may be possibilities that these two are at different locations. So I'm already connected with two different base stations, for example, master and the secondary, and I'm just moving across the geography. Then I can also get connected to two more base station again, then again two more base station. And in that case, one become master and one becomes secondary. So what happens is that handover failure rate will come down. So dual connectivity has advantage of improving the handover success rate. Then this is very interesting philosophy. And then coming to the coverage, right? So when we talk about coverage, we talk about the heterogeneous network, small cells, interworking with macro cells. All those things will come to the part of coverage typically, right? So with the macro cells, my coverage will go maybe with the macro, my coverage can be 3 to 5 kilometers. But when we have micro cell, my coverage can be very less. But the main motive of pico cell, micro cell, small cell is to provide better quality of service with the help of dual connectivity, right? Moreover, in case of 5G, we have various bands like we have low band, we have mid band, we have high band. And if you remember in my previous class, we are divided into FR1 and the FR2. So FR1 is between 400 megahertz to 7 gigahertz, and FR2 is between 24.2 gigahertz to 52.6 gigahertz, right? And as you know that millimeter waves has very less propagation. They do not travel for a long distance. So, but they have high bandwidth. It can go up to maybe 400 megahertz. That's why it is very useful to improve the capacity, not the coverage. So the idea is that master node should be in the coverage layer, best coverage layer. Maybe it can be 700 band, 850 band, or low band, any kind of low band. So you want to put the master node on the coverage layer that has the best coverage, right? The aim is to get the ubiquitous coverage for the master node, and then you can go ahead and use the resources from the secondary node for improving the capacity, right? And then we have load, or you can say load balancing, right? So what is the main aim of load balancing? As you know that everywhere there is an uneven traffic. So if you go to mall, right, if you go to mall, so many people are there and all the traffic at that mall. But if you go to nearby ground, right, there may be ground nearby, or there may be area where there is less traffic. But both of these sites are taking equal resources from the network, right? So in that case, there is a uneven traffic, right? So what it brings? So it brings lots of higher call blocking rate here, right? And our network will not be efficient. So there will be a high dropping calls in the hotspot. In contrast, large amount of resources will be unused and there will be the idle state. So we should reduce this wastage of resources. We should improve our throughput. For that, load balancing is very much required. And with the help of this dual band, load balancing will improve, right? The aim here is to redistribute the traffic load evenly among the neighboring cells. And then we boil to the last point, which is optimal network performance through flexible use of radio resources, right? So you can see here the word radio resources, very interesting, right? So as a RAN person or a radio person, we always talk about how best we can utilize the radio resources, right? So it could be LTE or it can be 5G. So we make sure that radio resources should never get wasted, right? For which we also have to proper planning the network. We also make sure that take the advantage of dual connectivity and stating that, so if one base station is overloaded, I can offload to other base station. It could be Wi-Fi offloading, doesn't matter, but the philosophy is typically a part of dual connectivity, right? And other benefits which are not mentioned here, there can be some business benefits, like it can be you can say faster time to market with the help of this dual connectivity, right? Also, we have initially lower initial cost of deployment. So these are the few benefits of the dual connectivity. Okay, so let's jump to the next topics, carrier aggregation and the dual connectivity. So fundamentally, let us try to understand the difference between carrier aggregation and the dual connectivity. So let's talk about carrier aggregation first. So in CA, there is a, so when I use the term CA, always remember I'm using the term carrier aggregation. Okay, so CA is carrier aggregation. So in CA, there is a base station. It could be E node B or G node B. So in this particular example, we have G node B because we are referring to SDAP. So SDAP, as you know, it's Service Data Adaptation Protocol. This is a new protocol in case of 5G. So now the question is whether 5G supports CA or not. The answer is yes. 5G supports carrier aggregation. But the point is that how this CA and DC are different, right? So here we see we have various layers like MAC layer, RLC layer, and the PDCP layer. And here you can see the SDAP layer is, which is used to provide quality of service per packet by packet. And I'm providing a specific quality of service. Accordingly, my PDCP performs packet pushing to RLC and then it pushed to the MAC, right? So here the MAC is very important because scheduler is the part of my MAC. So here scheduler work is very important, right? So MAC, the function is related to scheduler, right? And here you can see two carriers, carrier 1 and the carrier 2. So all the packets come up to the MAC layer. So packets starting from here, like these packets starting from here, and after that they come to the MAC layer, right? And after coming to the MAC layer, we know we have two carriers, carrier 1 and we have carrier 2. So what I do, so based on the load balancing or RSRP measurements, I'm going to put into two different carriers. So you can see the packet 1 or this purple package and blue package are going to carrier 1, and this green package and yellow one are going to carrier 2, which is secondary carrier, and carrier 1 is the primary carrier. So this is a simple carrier aggregation, right? So this is fine. So just remember one thing, we have only one scheduler in case of carrier aggregation. This thing we should remember because we have only one MAC layer in case of CA, right? But now we have this dual connectivity. So in dual connectivity, as I said earlier, there will be one master node and there will be one secondary node. And we are just right now we are assuming that both are G node B and both belongs to 5G. So here I'm going to send packets because this is the master node. So I'm sending the package from here, right? You can see it is providing certain amount of quality of service and the PDCP. Now this PDCP is going to send RLC MAC into the secondary node and RLC MAC into the master node as well. You can see here, one is master RLC, one is secondary RLC, right? So this is also called, this red line, this is also called forwarding tunnel, and it is, since it is 5G, they are connected through XN interface. Okay, having said that, so the packet will come through the forwarding tunnel to our MAC, RLC and the physical layer. So you can see here we have two schedulers. One is scheduler 1 and this is scheduler 2. So they are two different schedulers. So one scheduler in the master node and other scheduler in the secondary node, right? So they are going to actually take a different sets of measurement from the UE. So UE is a dual connectivity capable, right? So this UE should support both LTE as well as 5G, right? So link 1, link 2 is nothing but say this could be carrier 1 and this could be carrier U, whatever, right? So this is a fundamental difference between dual connectivity and the carrier aggregation. So when the dual connectivity comes into picture, we have two schedulers, but when carrier aggregation comes into picture, we have only one scheduler, right? So guys, if you understand this concept, can you please write yes in the chat box? Okay, great. Dual connectivity. So in carrier aggregation, we have only one scheduler, and in case of dual connectivity, we have two schedulers, right? And in carrier aggregation, we have one primary cell and we have this secondary cell. Okay, so in case of carrier aggregation, so one is primary cell, one is secondary cell, and primary cell is the anchor node because all the RRC and all the SRBs goes to this primary cell source. So next topic is multi-rat dual connectivity in 5G. So we should remember these terms always. So here, first thing is that MRDC with EPC. Here we have MRDC with EPC. So whenever MRDC means multi-rat, multi-rat dual connectivity with EPC. So in that case, LTE is the master node and 5G is the secondary node. Okay, this we should remember. And then if we have core of 5G, we have 5G core, right? So here we have two different concepts. So here you can see here NG-RAN, E-UTRA, NR dual connectivity. So new generation radio access network, E-UTRA. So E-UTRA means LTE and NR means 5G. So you can see E-UTRA is written in front of NR. So whenever E-UTRA is written in front of NR, in that case, LTE is the master node and 5G is the secondary node. But in case of, so now in second case, NR is written in front of E ultra, right? NR E ultra dual connectivity. In that case, G node B is the master node and E node B is the secondary node. Okay, this we should remember. And these are the main concepts which we have just discussed. One is ENDC and one is EN G node B. In case of ENDC, E means E ultra, or you can say LTE, and N means NR. So here in this case, E node B is the master node and G node B as a secondary node. And here we have EN G node B. In that case, G node B act as a secondary node that is connected to X2 and the S1U. Okay, so this is, we are using EPC, means evolved packet core. We are using the 4G core. In that case, NR will be secondary and LT will be the master node. So let's talk about some of the concepts for dual connectivity and what are the various options we have in case of dual connectivity. So here in dual connectivity, we have 4 possibilities. So first one is ENDC. So first one is ENDC, E-Utron NR DC. Right. So frankly speaking, this is one that I see being dominant today. All right. So this is already being launched and mostly used by existing LT carriers. All right. So first of all, no 5G core, and this is 4G EP. So this option allows an existing LT operator to deploy the 5G RAN without using 5G core, and that is very different than when we rolled out LT, right? So because when we rolled out LT, we rolled out LT as a whole. We are not taking like small parts of 3G and some parts of LT, but we rolled LT as a whole. So this stands out different in case of 5G, because here we don't have 5G core and we are launching the 5G, right? But here one thing we should understand, that instead of G node B, you see here one term called E node. You see here one term called, so you see here G node B. In addition to G node B, you see here 2 letters. One is EN G node B. Why we call it EN G node B? Because it has to talk to LTE core. Since it is talking to LTE core, so it should understand LTE or 4G protocols. That's why it is called enhanced G node B, or you can say E-Utron G node B, right? So it is called EN G node B. And here E node B is the master node and EN G node B is the secondary node, right? It is called ENDC. So what does it mean? That G node B should understand the 4G protocols. That's why it's called E node G node B. So we are going to interconnect these through the X2 interface, because we are talking about 4G and we are X2 interface, and we know that X2 is E node B to E node B connection, but now we can use X2 between LTE and 5G as well, right? So X2 is not a 5G interface, it is a 4G interface. That's why you have to understand 4G protocol as well. So this G node B should understand 4G protocols. All right. So now the G node B has to understand X2 and also has to understand S1U, because this is a 4G, right? This has to understand S1U as well. So big takeaway, we are going to deploy 5G RAN on the top of 4G RAN and co-site them, and the 5G node has to know the 4G protocols, right? All right. Then we have next 3 options. In next 3 options, we are going to use the 5G core, right? So first option you see here is the NG Ultra NR. So NG is the, you know, it's new generation. So E Ultra is LTE and NR is the 5G. So here you see here that E node B is the master node, LTE is the still master node, and G node B is the secondary node. But one thing we should see here, that in addition to E node B, there is a 2 letters added, which is called NG. Why it is added? Why it is called NG E node B? Why it is called new generation E node B? Because now we have 5G core, and this E node B has to understand 5G protocols. That's why it is called NG E node B. Okay, and these 2, since we are using 5G, and these 2 are connected through the XN interface. Okay, so this is a difference between this one and this one. Here we are using 5G core, right? Then we are going to do is, we are going to flip-flop the roles of 5G and the 4G. So here you can see that G node B becomes the master node, right? Here, G node B is the master node and E node becomes the secondary node, right? But still it is called NG node B because first of all, it has to be connected with G node B with the help of XN interface, and then we are using 5G core. So it is called NG node B, right? New generation E node B. All right. Just like we did over here, but here roles are flip-flopped. Again, G node B is the master node and E node B has secondary node, and it is called G node E node B because it has to understand the 5G protocols. It has to understand XN interfaces up to the core, right? And then last option we have is NR. So we have a G node B is the master node and G node B is the secondary node. Theoretically, this is like multiple years out in the future, maybe 2-3 years in the future. So guess what is happening in this case? 4G technology is gone. So here you will see just 5. So what's the situation today with the UMTS and LTE? A lots of operators today have basically already got rid of 3G and they have already got rid of UMTS, CDMA. So if you remember that, and now there is LTE and it takes time to do that, right? So many operators, I would call it 90% LTE or maybe 10% 3G. And, it depends on operator, country, and how fast things move in those countries. But it is already happening. So that's why it's going to eventually happening that LTE will go away and 5G will come as a standalone. So although LTE is a long-term evolution, so expect 5G to be there for a long time. So this is option here. So you have G node B is the master node and G node B is the secondary node, right? So again, what is dual connectivity? So dual connectivity was introduced in 3GPP to allow a UE to simultaneously transmit and receive data on multiple component carriers from two cell groups, master node B and secondary node B. And DC can increase user throughput, provides mobility robustness, and the support load balancing among nodes. Right. So the next topic is 5G deployment options. Friends, thanks a lot for watching the video so far. Before going further, I request everyone, please like this video and share this video with your friend. Moreover, your comments mean world to me. So do not forget to comment on this.